All right, so let's look at this transformation that's defined by the matrix multiplication AX. So is B in the range of A? So what they're saying is, can I get to this from some X? Is there an X that works? So from the domain. All right, so let's put together our augmented matrix. So 1, -3, 5, -5, -1, 0, 1, -3, 5, 1. So putting this into your calculator, doing reduced echelon. So I got this for the first row, this for the second row. Okay, so remembering this is an augmented matrix. So that means from here, I'm going to get some solutions, right? It looks like I have a pivot here, a pivot here, and a pivot here. Okay, so now let's look at the question. Is B in the range? Is it asking me for the exact solution? It's not. It's not asking me for what the X is that goes to this vector. I can see by looking at this by the pivots, and this is augmented matrix, right? So this is an equal signs where I've drawn the dotted lines. I can see that this is consistent. So therefore, yes, B is in the range. I can get to the vector B from vectors X in the domain. Infinitely many, because I can see there's going to be a free variable. All right, so there are facts about a linear transformation that I want us to practice, and you'll be doing this more in time to come. I just want to illustrate this to show you how to do this. So these are two true things about linear transformations. So if I take a transformation of two vectors, u plus v, it's the same as saying take the transformation of u plus the transformation of v. The second is if I take the transformation of a constant times u, it's the same thing as pulling that constant outside and then taking the transformation of the u. All right, so I'm going to show you with examples first, just so you can see the numbers happening. So if this is the u and this is the v, and this is my matrix A. So if I take u and v and add them together, I get this. So now if I'm going to take the transformation of the u plus the v, which is this, right, and put it here. And so remember, the transformation means multiplying by the matrix A. So here's the matrix A. Multiply it times the uv, I get this, 11 or 25. All right, so that's this side. So now let's find out what the transformation of u is and the transformation of v individually. So that means take the matrix A, multiply it times u, I get this. Take the matrix A, multiply it times V, and I get this. So now taking these two, adding them together, I get, oh, look at that, the same thing, they're equal. So I've shown this equals this. All right, so same kind of idea. If I take a constant and multiply it into the u, it's the same thing as saying the constant times the transformation of u. So remember that a constant times u just means you multiply the c into both parts. So let's just use an example, use 3. And so the transformation of 3 times u, so 3u would be 3, 6. So multiplying the matrix A times 3, 6, I get this. And if I take the transformation of u, which we already found up here, right? The transformation of u is 511, and then multiply it by 3 after, it's the same thing. So this is illustrating that this is a linear transformation. So let's move on to some more definitions of things you'll need to be comfortable and familiar with. So I've already talked about this as being like the 1 in matrix land. And so if we're in 2 by 2 matrix, then this is the 1. Now this only works when we're talking square matrices. And we call this first column vector E sub 1. Remember, if it's capitalized, that means it's a vector. So this is E sub 1. And then this would be E2, right? This is E2, and this would be the column vector E2. All right, then if we were in 3 by 3 matrices, then this E1 is this column vector. And then this E2 is this column vector. And then this E3 is this column vector. And so it is like a 1. All right, so let's talk about how we're going to use these two things. So if I've got a matrix, a transformation going from R2 to R2, then I know my A is a 2 by 2 matrix. And let's talk about our 2 by 2 identity matrix, which is the 1, 0, 0, 1. And so what I'm going to do is I'm going to tell you what the transformation does to these identity matrix vectors. So the E sub 1 gets mapped into or transformed into this. The E sub 2 gets mapped into this vector. So translated with the matrix, so T sub E1 is 2, 5, T sub E2 is 1, negative 1, 6. Okay, so now if I want to find out what this vector does, where does this, so this would be talking in the domain, right? So I'll put 5, negative 3 here in the domain. Where does it go when I multiply by A? So let's check it out. So what I'm going to do is I'm going to write this vector that's in the domain, and I'm going to write it in terms of these E vectors. So this would be the same as saying 5 times 1, 0, minus 3 times 0, 1. All right, so then I'm going to do the transformation on 5, negative 3, right? Because I don't know what the matrix A is, but I can see what it does to the identity vectors, E1 and E2. So since I know it's a linear transformation, I can split it up around the addition or subtraction. So I split it up around the subtraction here. And then I'm going to pull this number 5 on the outside of the transformation. I'll pull this number 3 on the outside. And so I know that T of E1 is 2, 5. And I know that T of E2 is negative 1, 6. Because they told us that in the beginning, right? When we wrote it like this. So then I just multiply by 5 and multiply by negative 3. Add them together. That's the vector. The transformation takes this domain vector 2.